Okay, let's get going with some trig equations. So in the last lesson, I think this table gives a good summary of what we learned to do. So let's just have a quick look at this table. Just give me a thumbs up if you can see the print okay. You can see the print okay in this table. Okay, fantastic. Okay. Simtanda, can you see okay? Fantastic. All right, so basically we have three different trig equations in this table. We have a sine one, we have a cos one, and we have a tan one. And in each of these, what we notice is that we have to always find a reference angle. And so in the first one, the reference angle ends up being 45. In the second one, the reference angle is 30. But something that's important is when we calculate the reference angle, we actually ignore the negative. You'll notice that we ignore the negative. And the reason we can do that is that in step 2, when we deal with quadrants, we take it into account. And then for tan, that was negative. So we ignore the -1 and we end up with a reference angle of 45. Then in step 2, we basically decide which quadrants the solution to the equation have to be. And in this one over here, it's in quadrant 1 and quadrant 2, because that is where sine is positive. Whereas in the cos one, we're going to be in quadrants 2 and 3, because that is where cos is negative. And then for tan, well, actually with tan, because of the period of the graph being 180, we could go to quadrant 1 or quadrant, actually, wait, hold on, wait. Tan is negative in this one. So tan is negative in quadrant 2 and quadrant 4. But with tan, you only need to do one branch of the solution. So we do quadrant 2. And then sometimes you only have to calculate the answers in the interval 0 to 360. But more and more today, we're going to be moving to what's called the general solution. And the general solution is where this extra bit gets added on. So we've got the two answers, 45 and 135, but we add on a k times 360 because that's the period of the sine graph. We add on a k times 360 because that's the period of the cos graph. And then for tan, the period is 180 by default. And you'll also see this k is an element of the integers. So this summarizes what we did in the last lesson. Give me a score out of 10 about how well you understand this table, where 10 is a very strong understanding and 0 is nothing and 5 is like okay understanding. I want to know, how confident do you feel in carrying out this method? And then I know how many revision questions I can do, or if I can skip straight to the harder ones. Let's see those scores in the class here. Okay, keep coming. This is very helpful. I want to see what is your self-perception of how much you understand? Okay, so what I think we do need a couple of warm-up examples. And so what I'm going to say to you is, I'm going to ignore what they say about 0 to 360. I want us to find the general solution to this trig equation. And I also want us to find the general solution to this trig equation. So I want you to do these two, A and B. So we'll call it 1A and B. I'm crossing out the other ones. We don't have to deal with those. And each of these is going to have a 3-step process. Step 1, step 2, step 3. And I want you to do them for me now. While you do them, I want you to tell me what your reference angle is in both of these. I want you to tell me what quadrants you are in, and then I want you to tell me what your final answers are. Okay. Give me a thumbs up if you know what you have to do, and I can just sit and wait for questions. Give me a thumbs down if you're like, what is this guy telling me to do? Okay. Well, then I believe it is over to you guys. Fantastic. Welcome to Sange and to Gundo, who also joined us. So what is my reference angle that I'm getting? I'll watch the chat for a bit. Okay, so Gundo, what you need to do is the two questions. The first question you're going to do is this one, and you're going to start by finding the reference angle. And the reference angle for sine of x equals 0.2 is going to be inverse sine of 0.2. So Gundo, I want you to tell me what angle do you get when you go inverse sine 0.2? So you tell me what that is, and then we'll move on to the next step together. Who's got a reference angle for me? So Gundo has got 11.53, and I think that sounds pretty good. Does anybody else get 11.53 for their reference angle? Fantastic. Okay, now, where is sine positive? Because 0.2 is positive 0.2. So which quadrants do we need to be in for my answer? Which quadrants do we need to be in? Well, if you get forgetful, don't worry. You can always go back to the cast diagram, and it's sine, and sine must be positive in quadrant 1 and quadrant 2. And so in quadrant 1, my solution will be a reference angle of that, and in quadrant 2, it'll be 180 minus the reference angle. So my two solutions will be in quadrant 1 and quadrant 2. The question is, I did ask for a general solution, so I want a general solution. But before we can get to the general solution, I want to know what is x equal to here and what is x equal to in quadrant 2. Ruli agrees. It's quadrant 1 and 2 for my answers for the yellow one, which we're currently doing. So I want to know what are my two answers that I'm going to get for the yellow one. I feel like quadrant 1 is a little bit too easy. It's just 11.53. What's quadrant 2 going to be? Is it going to be 180 plus, 180 minus? I think this is going to be 180 minus 11.53, which gives me 160. What's that going to be? 168.47. But this is not a general solution. To become a general solution, you need to add the multiples of the period. So k times 360 for this, and k times 360 for that. And then you also need to describe what k is. So my two answers are x is 11.53 plus k times 360. And the other answer is x is 168.47 plus k times 360, where k is an element of the integers. Okay, let's move now to the green one. So I want to start by asking, I'm even going to change the color to green. Step 1 is always to find the reference angle. What is the reference angle for the green one, or for B? Let's start with that. And I'll wait for some answers to come through. So the reference angle that I'm getting from the class is the important thing that I need people to notice is that you ignore the negative. Whenever you find the reference angle, you do not worry about the negative. And you should be getting 72.54 or 72.5 if we round off. Now, that was step one. Step two is what quadrants are my solutions going to be in? So what quadrants am I going to be in to solve these? I need to know, this is where where is cos negative? It's not quadrant 1 and 2. I can tell you that. What quadrants am I going to be in when cos is negative? Negative 0.3. I think we are going to be in quadrant 2 and quadrant 3. And that's where it's 180 minus the reference angle, or it's 180 plus the reference angle. So for step 3, I'm going to do 2 Roman numerals. And I want to know x is going to be equal to something, or x is going to be equal to something else. I want to know what are those somethings that I am looking for. So what's in the blue box? What is in the red box? Remember that the reference angle was 72.5. And let's get rid of this little thing on the left-hand side. It's just taking up space and it's not adding any value. What do we think goes in box number 1? Well, 180 minus 72.5 will give me 107.5. And over here, 180 plus the reference angle is going to give me what? 252.5. Now, these are specific solutions, but I want to make this a general solution. What do I need to do to make this a general solution? Who can put their hand up and tell me, or who feels like they know how to make this a general solution? Yep, it's just the k times 360. And what that is doing is it's just saying you can get another solution if you add 360 to this, right? So we just go plus k, and then we say where k is an integer. So just to show you how this works, so not only is 107.5, if I needed to generate more solutions, another solution to this equation could be, if k was 1, I would just add 360, or another solution would be 252.5 plus 360. Now, I want to know, if I wanted to generate these other solutions, what would be in the green box and what would be in the black box. Now, this is no longer, I'm actually using the general solution to make more solutions. But I just want to test that you understand this idea. So tell me what another set of solutions are to this equation, because I've added a multiple of 360, and I want to see, can you get what's in the green box and what's in the black box? So this one is going to be 467.5. And what is the black box going to be? What is the black box? Guess 300 plus 200 is 560. And then I think I go over into 600s, basically, because in my head, what I get is 612.5, but who knows if my brain is working correctly. So what do you guys get? Do you get the same as me? Yeah. Okay. Now, if you put this in your calculators, what do you get? If you type in your calculator the cos, just to show you that this really does work, 467.5, what do you get if you put that in your calculator? And bonus points if you know what I'm hoping for. What do you get if you put the cos of 467.5 in your calculator? minus 0.3. Isn't that a wonderful coinkydink? Well, it's not really a coincidence, is it? I knew that because this is a true answer, it had to give me minus 0.3 because that is what the question started with. And so I feel very confident that I know what I'm doing with trig equations because the numbers are adding up. Okay, so we have handled the standard trig equations. What we need to do now is start to deal with some more exciting ones. So let's have a look at this type of trig equation. Let's start by opening the conversation, asking what is different about this trig equation compared to the ones we've done so far? Who knows what is different about or can spot something different? Who can spot something different about these? Or this one in the black box at the moment? What stands out to you as different? Two angles, sort of, or I would say there's a double, there's a 2 in front of the theta. For bonus points, does anybody know theta is multiplied by 2? Exactly, that's where the action is happening. Now, in the world of trig graphs, what that 2 actually does is it changes the period of the graph. Now, we're not going to go too much into trig graphs right now. We're going to do a whole unit on trig graphs later. But really what the 2 there does is it takes the normal period of the cos graph, which is 360, and it divides it by 2. And you'll see that as we do the question. But the good news is when you start, all you do is you start with the reference angle. So there's a 3-step process that I'm going to lead you through to solve this. And that's what's so awesome. So find me the reference angle for this particular thing. And I want you to ignore, you don't have to deal with the yellow bit in the first step. You can just ignore it. So find me a reference angle for this trig equation. Okay, so I'm going to go cos, but I'm going to go inverse cos. And what's more, I ignore the negative. So it's 0.6427. I ignore the negative, and what do I end up with as my reference angle? Sange has got a 50 in the mix. Can anybody support Sange in the answer of 50? See, Tanda is with you, Sange. You've got someone who's supporting your answer. Anyone else get a 50? So you go shift cos 0.6427, and indeed the answer, I think if it's rounded off, it's 50. It might be like 50.00, something around that level. Okay. Now, the question is, where is cos negative? Because clearly cos is negative here. I want to know in what quadrants is cos negative? Well, I think I remember because positive here and here, negative must be here and here. And this must be 180 minus the reference angle, and this must be 180 plus. But here's the thing. That's perfectly correct. So you need to write down that you will have an answer in quadrant 2 and quadrant 3. So perfectly fine. But we need to deal with this 2 theta. And you know where the 2 theta comes in? It comes in now. So we are going to say, instead of x, normally we write x, now we write 2 theta because or 2 theta equals, and we're just basically writing down what is inside the trig ratio. But we do not write 50 here. What do you think we are going to write inside this box over here? Using what we've learned so far, and what do you think we're going to write in the blue box over here, just using the methods that we've used so far? It's not going to be 50. In quadrant 2, it's going to be 180 minus 50. And then what's going to be in quadrant 3's box? I think, following the same idea, it should be 180 plus 50. But it said it's a general solution. So what do I still need to add to my trig equations that I'm solving? What have I left out that it would make it become a general solution? Yep. So we go plus k times 360. Sorry, my k's are a bit squished. Yeah, Ruli, let's go to you. What is your question? Can you hear me, Ruli?
Yes, sir. Can you hear me?
Perfectly, loud and clear.
Okay. So I have a question for when it says 2 theta. You said that we
Yeah.
changed the, but can I ask what's the difference between you dividing both sides by 2, then dividing the period by 2?
Okay. I'll show you now when we do this. This is a very good question. So, Ruli, have you noticed that the period is still 360? I haven't changed it yet. Hey, did you notice that? It's still the normal
Yes.
period. Okay, now what's going to happen is the magic is going to happen in this next step. So watch this. Are you happy that I get 130 plus k times 360? Are you okay with that so far?
Okay, yes.
Because, okay, and then on this side, I've still got a 2 theta, but this one is going to be 180 plus. So this is going to be 230 plus k times 360.
Yes.
Okay, now I
Okay.
have to deal with 2. And what you were saying was I have to divide both sides by 2. So essentially what happens is I have to do that. And what that allows me to do is to say, look, this becomes theta by itself. So what is 130 divided by 2?
65.
Okay, now we're absolutely correct, but we can't stop there because the period has to be changed as well. So what is 360 divided by 2?
180.
Okay, now this is good news because remember I told you at the beginning the period must be changed, but let's do this one. Or theta is equal to, what's 230 divided by 2?
115.
Okay, and then we know for the same reason it must be this. So the final solution is actually 65 and then any multiple of 180 that I add or subtract to that, or it's 115 and every 180-degree multiple of that. And just so we can check our answer, I tell you what, let's just do a little sub back in. So let's go cos 2. Now, if I double 65, I get the cos of 130. If you type the cos of 130 in your calculator, Ruli, what do you get?
Negative 0.64278.
And that's good news for all of us because that is what we started with. Can you see that?
Yes, sir. Can I ask if I
Yeah.
divided cos 2 theta first when
Yes.
getting the angle, is it the same thing?
No, it's not. So unfortunately, that would be wrong. You can't divide the 2 until the very last step. If you do it earlier, you run into problems. And that's one of the main reasons why I teach this method step by step. You have to leave, it's almost like it's locked away, really. So inside, it's almost like you think of it as locked away, and it only gets unlocked in the last step over here. Can you think of it like that?
Okay.
Okay, and we're going to do that after the break. What we're going to do is we're going to do a lot more of these. So this was the first one where we could see it, and you'll see by the end of today, you'll find this easy. But thank you for your question. I think you helped a lot of people, not just yourself, by doing that. Okay, you know what I like after some hardcore maths is a good exercise break. So I want everyone to turn on their cameras, and I want you to join me in taking care of your body so that your brain can function. I know I sound like an over-enthusiastic teacher, but I really believe that giving your brain a break means you learn better, and actually it's less stressful and less tiring. So you get better at maths if you're fit and you take care of your body and you breathe and you do these things that I do. So it's not just to be silly that I do them, I promise. There is some science behind this. So let's start with some deep breaths to get oxygen into our brains. Let's go. Hold your breath when you take it in and breathe through your nose. One more deep breath. Okay, so you should have some oxygen in your body. That's going to help your brain reboot. Now you want to do is relax your body so your brain doesn't feel stressed. You're just going to shake out an arm like it's nice and floppy. If your arm isn't floppy, it means you're too tense. So take this arm, just make it nice and floppy, wave it around like you just don't care. Shake your legs out. You're also hopefully getting some circulation going in your body. So you've been sitting down, you've been scrunching over, you've been getting tight. You want to loosen up and get nice and relaxed. Okay, let's roll our shoulders. We roll our shoulders back. Also, you want to feel your shoulders just relax. You know, and then you roll them forward. Okay, then out to the side, we can just do some light circles going forward. And then we can do some light circles going back. Yeah, I'm definitely feeling more relaxed as I do this. Okay, one more shake of the arm, shake of this arm, shake of this leg, shake of that leg. Okay, so now we need some blood pumping through our bodies. I haven't found an exercise that's better than jumping jacks. So if you have one, please let me know, but it just works. The only ones I know are things like mountain climbers and stuff like that, where you're on the floor, and that won't work for this context. Okay, we're going to do 15 jumping jacks in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I can definitely feel my legs working to push me off the ground. And then the last step in our brain break is just to unwind by solving some fun little puzzles. And I want you can solve any of these 3 that you like. Tell me how you would make 24 using either the red card, the blue card, or the yellow card. Anyone can solve them. All of them have letting your brain get distracted. And it's almost like letting your brain relax for a bit. So who can tell me, I can feel my breath is still catching up. Who can tell me how to solve one of these cards? Who feels like they're a Maths 24 natural? Will it be Sange? Will it be Simtanda? Or Ruli? Or will it be Stephen? Oh, welcome, Stephen. And Zelinda, Josi, Gundo. Who feels like they could just smash a Maths 24 puzzle quickly? We've got to do at least one. I'll give you a hint for the red one. Take 7. So go 7 minus 5. What do you get if you go 7 minus 5? And how can that help you? Or can it help you? It can help you, yeah. So 7 minus 5, what do you get? I think you get 2. So who can make 24 from that point? You've used up that. You've got an 8 and a 1 left. Ah, really? Have you got the blue one? I do believe you have. 8 times 2 is 16. And then, so you took out that one. And then you just added a 7 and a 1, and you absolutely made 24. So really, that is your puzzle for the day. Well done to you. You are the champion. CM Tanda has said that in the red one, you take the 2 and you add a 1 and you get 3. And then you take the 3 and times it by 8 and get 24. And so CM Tanda, you claim that card. Can anybody grab the yellow one before we move on? Maybe we can come back to it. We shouldn't, yeah, we maybe should go back now, but I like that. That was good. Well done. We solved 2 of the Maths 24 puzzles, and we will come back to that in a future lesson. Okay, let's go back. How are you in terms of, I'm always curious. So in terms of feeling refreshed, how is your attention feeling now out of 10? Where 5 is like middle attention, 0 is little attention, and 10 out of 10 is like you have good attention to concentrate now. Let me know what your attention is feeling like. I'm going into this next part of the lesson. Out of 10, give me a score out of 10 about how focused are you feeling? Do you feel like you have some maths brain back with you? Okay, fantastic. Let's go. That is the point of the brain break, so I'm glad to hear that. Let's start with this one. What do you think my first step is going to be in solving the trig equation, the cos of theta plus 25 equals 0.231? What do you think my first step is going to be? And it's a general solution. CM Tanda, let's go to you. What do you think my first step is going to be?
We take cos to other side, so we're gonna do the, can't remember what it's called, but we're gonna go shift cos on a calculator. Go through,
Okay. I sort of, well, I think, were you trying to say the reference angle, CM Tanda? Because,
yes.
Okay, so what I would go, I'd take cos, you're right, you're undoing the cos, which would be called inverse cos, and you take it of 0.231. So you basically, I get what you were saying. You were saying, look, you need to use inverse cos on both sides to get this thing out. What reference angle do you get?
76.64 degrees.
76.64. I'm going to round it off to 76.6. Fantastic. Thank you, CM Tanda. That was great. I'm going to ask someone else to help me with the second step, but that is exactly the first step. What is my second step going to be? You can put it in the chat. You can raise. It's quicker if you just put your hand up quickly, but I will take suggestions from everyone. So Sange, I see in reference angle. You're absolutely right. What is step 2 going to be? I feel like it's going to be the same thing we've been doing all along. It's going to be find the correct quadrants. And it's saying cos is positive, which means it must be in this quadrant or that quadrant, which is just the reference angle or 360 minus. So the third step is going to be to say, look, I have an answer in quadrant 1, and I also have an answer in quadrant 4. Okay, now I'm going to write something down on this side, or I'm going to write something down on this side, and then I'm going to have equals, and there's going to be other stuff. I want to know what is inside the red box. What do you think is going to go inside the red box? If you think about the last time we did this, didn't we just pull what was inside? It was locked away. That was what I was saying to Ruli, that it's locked away. We can't touch it yet, but we can bring it down. We've broken it out using inverse cos. I think I'm just going to write down what's inside that thing. So it's going to be theta. Oh, there we go. Sange said it's theta plus 25. And the same thing is going to be here. It's going to be theta plus 25. Now, here's the thing that we watch out for. In quadrant 1, it's just going to be equal to 76.6. But in quadrant 4, what is it going to be equal to? So in quadrant 1, theta plus 25 is 76.6. But in quadrant 4, what is it going to be equal to using the ideas that we've learned so far? Pop your contribution in the chat. Thank you, really. Indeed, it will be 360 minus 76.6, which gives me 283.4. Now, it did ask for a general solution. So I'm going to go k times 360 because that's the period of the cos graph. And then I'm going to go plus k times 360. I'm going to do that. Okay, now, I would really like to get theta by itself. Or I'd like to get theta by, no, the k, that's fine. That's not going anywhere. But I want to know what goes in the blue box and what goes in the green box. Using whatever skills you've got about solving algebra, you know that you want to get this thing by itself. And you need to think about what do you need to do and what will that you end up with? What's in the blue box? What's in the green box? If anybody is feeling brave, they can even just put their hand up and talk me through what they did. So I was thinking that this 25 has got to go. But the question is, where does it got to go? Well, I think I have to take away 25 from both sides. And if I do that, I'm going to get 51.6 on this side. And then on this side, I'm going to get, because I take away 25, the 283 needs to get smaller, and it's going to be 258.4. And then that is it. Now, what you'll notice is that I didn't divide the period by 2. The period stayed 360. Why? And this is like the harder question. Why did the period not change this time, whereas last time in the earlier question, I had to divide the thing by 2? What was different? Now, that's a hard question for me to ask, but I'm wondering, does anybody have any ideas they'd be willing to put their hand up? And just, even if you're wrong, I just want to hear some ideas. Who has an idea? Anyone? Any ideas? Really, I'm going to come to you and I'm going to ask you to unmute. Can you, what do you think? Hey,
It's because
yeah.
it's because theta wasn't multiplied by anything, it was just added by 25. But second,
Yep.
on the last step, we're going to do the inverse.
It's exactly that. There was no number next to the theta. So we couldn't divide it. The opposite of adding 25 is taking 25 away. In the earlier question, you'll notice that the question had a 2 next to the theta. And that meant not only did the 130 get divided by 2, but the 360 was divided by 2 as well. And so we call that a period change. It literally changes the period. But in this case, the example we just did now, that is just a horizontal translation. And so it doesn't change the period of the graph. Okay. I want to do this question over here, but I'm going to draw it bigger. So the next one you're going to do this all by yourself, is you are going to try, in fact, I'll write it below so we have some more space. Can you solve the trig equation, the sine of 2 alpha equals minus 0.327? And I want you to find me the general solution to that trig equation. Okay, now off we go. I want to see, can you do that? And if you get stuck, I want you to raise your hand, but I think you all know what the first step is going to be here. I'll even leave the last one up so you can see it. What do you think my first step is going to be? Okay, hopefully that's big enough that everyone can see. And then I want you to just tell me, as you do this, what are the answers you're getting? And I'm going to get some water while you fly solo for a bit. What reference angle are you getting, everyone? Notice how I ignored the negative. It's just a positive value that I'm taking inverse sine of. And Sange has said 19.1. That looks pretty good to me. Can anyone agree with that? Can I have a yeah or a plus? Or Stephen is agreeing. That is great news. Okay, step 2. And so is Ruli, and welcome to Amelia, who's joined us as well. So second step is, where is sine negative? And that tells us what quadrants our solutions need to be in. And sine is not negative in the first two. It's negative in quadrant 3 and 4, where it's basically going to be 180 plus, oh, this is too small. 100, I'm assuming a little bit. It's just, I haven't got control. So 180 plus the reference angle, or if it's in quadrant 4, it'll be 360 minus the reference angle. Apologies for the small things. So my answers are going to be in quadrant 3 and quadrant 4. But this is where I need to unlock this 2 alpha thing. So I'm going to write down 2, a little bit thicker, 2 alpha equals, or 2 alpha equals. And I'm going to say again, what goes in the blue box, what goes in the green box. And you let me know in the chat. What goes in the blue box, what goes in the green box. So this is 180 plus, so this will be 199.1, because it's this one over here. And then this one should be 360 minus 19.1, which I think is going to be, someone can help me, but 340.9. Yes, I'm feeling pretty confident about that. What have I left off if I want this to be a general solution? What have I left off if I want this to be a general solution? I've left something out. I've had a moment. Yep, it's just the k times 360, because that's the period, or that's the default period of the sine function, which we're dealing with in this case. but there is some changes coming. And the second step, and we've seen this earlier on, I want you to tell me now, what do you get for alpha over here? And what do you get for alpha over here? And then also, I'm not going to write down what yeah, I want you to write down the next two lines and just tell me done when you're done with those two. Just tell me in the chat when you're done, just say done, and then I'll write out the answer and you can compare. So I think I need to divide both sides by 2. So I get, what's that divided by 2? It's 99.55 or 99.6 if I was rounding off, but I have to divide this by 2. So I get k times 180. Because remember, I'm dividing the whole side. What am I going to get for this one? And divide this by 2. It's going to be 170.45 plus k times 180, where k is an element of the integers. And that is that. And what you'll notice is that the period, do we include the k at the end? Yes, you do. The reason you have to include that k at the end is the k can't have no meaning. What this is saying is that k may not be a fraction. It can only be a 1, 2, 3, or a -1, -2, -3. K may never be a fraction. If you don't put this in, then you may think, oh, k can be a half or it can be a quarter. So you do need to include that so that a general solution will always have a description of k like that. Okay, so Sangya, I hope that answers, but I think it does, yeah. Okay, let's try and squeeze in one more before we finish today. I want to find one which has a bit more. Let's do this one. I'll do. Let's set tan 2 alpha minus 10 equals 5. Tan 2 alpha minus 10. So I'll write it down. So tan 2 alpha minus 10 equals 5. Now that is a trig equation that has not only a number in front of the variable, but another something. So that's a good way to end tonight. We're going to solve this. And I want you to find me the general solution, or what we call GS for this. So this is what our final question for tonight is going to look like. What do you think my first step is going to be? What do you think my first step is going to be? I think you all know what it's going to be. I think this, yeah. Question is, what is the value going to be? Maybe that's a bit more exciting. What is the value of my reference angle? So Sange has said it's 78.7. So you just need to check if you go inverse tan of 5, what do you get? And Ruli has agreed. So we're happy that this is in fact the reference angle. Step 2, where is tan positive? Well, tan is positive here and here. Now, here's what's interesting about the tan general solution. Is because the period of the tan graph is by default 180, whatever solutions you get in quadrant 1, they will automatically be repeated in quadrant 3 because they're only 180 degrees apart. So it's not wrong to do solutions for quadrant 1 and 3, but you actually don't need to do the second set of solutions because they're contained inside, which is a bit weird, but it is what it is. And it's not wrong to do the full thing, but I'm going to save you time and just do the one. Now, I'm going to start by writing down the bit that's locked away in the equation. It's going to be 2 alpha minus 10. What do you think is going to go in my red box? What do you think is going to go in my red box? it is indeed just 78.7 because that's the solution in quadrant 1. Now, in order to make this a general solution, I have to add k, but I don't add k times 360. I add k times 180. And the reason is that the period of the tan graph is 180. So this is important. You are dealing with tan, and the tan function is not like sine and cos. Its default period is 180. But we have quite some things to deal with. We have to deal with this 2 and this minus 10. Who has an idea? What do I deal with first? Do I deal with the minus 10 or do I deal with the 2? If I use my equation logic. What do I have to deal with first? It's the 10. Yep. Whenever you want to isolate alpha, you're going to move the 10 away. And so your next line is going to be what? Well, add 10 to both sides, and then you get 88 plus 7 plus k times 180, where k is an element of inches. But now I still have to deal with this pesky 2. So what is my final answer going to be? What is my final answer going to be? I think I have to do that to get my alpha by itself. The question is, what goes on the other side? The k is definitely going to hang around. You halve this, you get 44.35, and you halve that, and you get k times 90. And so the final solution to that quite ski trig equation is going to be 44.35 plus k times 90. And what that means is one of the solutions is 44.35, but I could get another one if I add 1 times 90 to that. So another solution for alpha could just be 130. What would I get? 134.35 would also be a solution because I just added 90 to that. And that's why general solutions are so good. They give you one set of solutions, but you can generate more of them using the formulas you're given. Okay, now, there are many types of trig equations, but they are all going to come back to this idea that I've taught you. So if you see other types of ones, they will always have a little trick at the beginning, like a factorization or something else, but they're always going to default to this thing in the end. And I think these 2 lessons give you a very solid base from which to go forward and just smash trig equations.